Good morning, student. Let's start today's class. Okay. In today's class, we are going to study your unit 3. Our unit 2 or your unit 2 is completed. Okay. So, from today, we will start your unit 3, which is data encoding. Okay. First of all, let's first discuss about what is encoding. Okay. What do you mean? What do you mean by encode? Okay. Encode is the process of converting the data or a given sequence of characters, symbol, alphabets, etc. into a specified format for the security transmission of data. Previously, we have told that for security purpose or securely transmission of data, we use coding. Coding refers that that the data will converted to some specified format and in receiver that this specified or coding process is in sender side. Okay, and the receiver side, the reverse process means from that from the specified format we converted to our desirable in data signal. Okay, so that conversion of our data or sequence of character into a specified format or specified symbol is called coding or encoding. Okay, next, encoding techniques. That means the data encoding techniques is divided into the following types depending upon the type of data conversion. That means based on the data conversion, the data encoding is divided into four types. Okay, one is digital data, digital signal. That means digital data to digital signal conversion. Okay, this the simplest format digital encoding. Okay, of digital data is to assign one voltage level to binary 1 and another to binary 0. That means digital data ku that means for converting digital data to digital signal we use one simplest technique, that is we denote or we give assign the binary 1 to uh, some voltage level and binary 0 to another voltage level. Okay, that means here if this much voltage level, that is 5 volt, okay, we give binary 1. Okay, and this much or this much, okay, this much voltage level, let's say 2 volt, we give binary 0, and again 5 volt binary 1, again 2 volt binary 0. This conversion, okay, happened in digital data and digital signal. Okay, next, digital data and analog signal. Here what happened, the digital data is converted to analog signal to transmit in analog medium. That means to use the analog transmission facilities. That means when we want to use analog characteristic or analog transmission characteristic, we need analog signal, but we at that time we have only digital signal, so that we convert the digital data into analog signal and use the analog signal transmission characteristics. Okay, and the techniques are amplitude shifting. Amplitude techniques are what? Amplitude shifting king, ASK, and frequency shifting king, which is FSK, and phase shifting key which is PSK. এটা next ଆମେ coming class ରେ ପଢିବା. Okay, next is analog data digital signal. That means it is also similarly that when we want digital signal but we have analog data, so we convert that analog data to digital signal and transmit or use the facility of digital signal transmission. Okay, and the techniques which we used for this purpose is pulse coding modulation, PCM. Okay, next, analog data analog signal. Here we use or we convert analog data to analog signal, and the techniques we used for this purpose is amplitude modulation, AM, and frequency modulation, which is FM, and phase modulation, which is PM. Okay, these three techniques we use to convert analog data to analog signal. Okay, now discuss these four techniques briefly. First one is digital data and digital signal. Okay, first of all, what is digital signal? A digital signal is a sequence of discrete and discontinuous voltage pulses. Okay, before we discuss about the techniques used for converting digital data into digital signal, we want to discuss about some concept. Okay, that means before we studied about the technique of digital converting digital data to digital signal, we should know about these these concepts, or we should remind this concept for our better purpose. Okay, what is this data rate? You know the rate at which data flow or transmit is called data rate, and that this is represented by bps, what is bit per second. Okay, and length of data, or sorry, length of bit, that means time taken for transmission to transmitter to emit the bit. That means time taken for transmitter to transmit one bit is called length of bit. Okay, and modulation rate, the rate at which signal level the rate at which signal level changes measured in, that means the modulation rate. In modulation, what happened? In modulation, our message signal is superimposed or changed accordingly with the carrier signal. In previously we already seen that in modulation the message signal is changed or superimposed with carrier signal. So the rate at which our message signal is changed, that is called modulation rate. Okay, and it is measured in baud. Okay, baud, which is signal elements per second or pulse per second. Okay, then comes to unipolar. Unipolar means if the signal elements are have the same algebraic sign, that is all positive or negative, then the signal is unipolar. That means here is one is signal element. Signal elements means the wave or the cycle, half cycle or full cycle of that signal is called signal element. And if all the signal elements, all the signals have positive algebraic sign equal, all the is called is, that means this signal, if this signal, okay, this is one element, and this is one element, and this is one element, this is one element. All elements is positive. This is also positive, this is also positive, and this is also positive, this is also positive, this is also, all are positive. Okay, that's why it is called unipolar signal. Okay, and polar is, it is, polar means it is one logic state is represented by a positive voltage level and another by a negative voltage level. That means here, if a signal is this, okay, this is the 5 volt and this is minus 5 volt. Okay, this 5 volt and this logic state, this is one logic state which is, let's say, 1, and this one logic state which is, let's say, 0. Okay, this logic state, also this logic state is, both are called polar. That means one positive level voltage level, what is 5 volt, let's say 5 volt, and another one is negative voltage level which is minus 5 volt. These two are called, both are called polars. Okay, and here it is not a unipolar because this element of the signal is positive and this element of the signal is negative, and again similarly positive negative. So there is no this signal have this signal does not have all their element in positive or all their element in negative. There is mixing of positive and negative, so that it is not a unipolar signal. Okay, thank you.